Hey everyone, this is Mr. B, wanting to go over the Chapter 2 study guide with you. I'm intentionally not posting this answer key, so you actually need to watch through and fill in some of these, but if you want to just follow along and copy everything down as I do it, that's totally fine. Um, Submit this before you take the test, and you will get 10 extra credit points completed. So let's jump right into it. First thing, relation and functions. I'm trying to break this out into sections so you know exactly what we're looking for in these. This is a sixth of your test, 10 of 60 points. So make sure you focus on each section for the same amount of time, roughly. So first off, define the following traits of this relation. What we're looking for here is a set of ordered pairs. You can go through, you don't need to label them as you go through, like negative, oh, that's not -2, that's -3, -2, but we are looking for something like that. So I'm just going to go through and label all 9 points. Let's see, that's 4, 5, 6, 7, 8, 9. I'm pretty sure that's it. 1, 2, 3. Yep, there's 9 of them there. I'm just going to go across. Let's see, -2, 3, -1, 4. We've got 0, 4. 2, 5. Let's see, 3, 0. That's not very clear. 3, 0. 4, 0. 4, -2, and 5, 3. All right, what's the domain? That's all valid inputs. So I'm going to go through and just really highlight all of my x values. There's only 2 repeated, so I'm going to have, let's see, -3, -2, -1, 0, 2, 3, 4, and 5. Try and close this off with a little squiggly black. I'm very bad at drawing them. There we go. Range for this is going to be all y values. So let's see, are there any duplicates? Yep, there's a duplicate here, there's a duplicate here, there's a duplicate here. So let's see, I'm just going to go top down. Let's see, we've got 5. Oh, that's the wrong one. There we go. 5, 4, 3, 0, -2, and -4. Okay, looks like everything there. What point can we remove to make this a function? Well, that's pretty telling that it's not a function right now. Really, you can select either of these 2 points. Those are the 2 that are causing it to fail the vertical line test. If you write in both, that's fine. I'm only asking for 1, so you just need to write in 1. I'm going to pick 4, 0. All right, that's the entire section 1.1 done. And this is just determining whether or not functions are linear. So you can cross out or cross out the ones it's not, or circle the ones that are, or both. It's totally up to you, just as long as it's clear for me. Let's see. This one tricked up a couple of you. We're actually looking for, yes, this is linear. Even though there's a square root of 13 in here, it's still going to be linear because the x is not under that. Really, the slope of this function is square root of 13. So it's linear. It's not nonlinear. Next one here. There's a lot of extra information in this. We know that the slope is 3, that the point that it crosses through is, let's see, -2, 2. But that's all kind of irrelevant. We don't even need to worry about that. We're just looking for linear or nonlinear. This one is. There's no power or anything like that above that x. This one tripped up a couple of you on some of the homework. When we FOIL this out, we would get x squared, let's see, plus 3x minus 10. That x squared is definitely making this non-linear. So this one would be linear. I'm sorry, this one would be non-linear. Let's see, this one also tripped up a couple of you. Just because there's a square root in here It doesn't really mean anything. This is just telling us the y-intercept is square root of 2. So that's linear. A straight slope. This one, square root of 2, square root of 2, x to the power of 2 would make this non-linear. So that would be full points for another section on the quiz, or the test. This one's all about determining slope. 2 points each, so, 1 point here, 1 point here. All of these are 1 point. So if you get a little bit lost, at least write in something. It's important that we're at least trying. So I'm going to take this first one, y1 minus y2. So I'm going to, let's see, or y2 minus y1. Doesn't matter which way you go. It'll just kind of move a negative around, possibly. So let's see, 2 minus 1 over negative 2 minus 1. So we would get 1 over negative 3. So I'm going to write the initial slope as 1 over negative 1 over 3. And the perpendicular slope, I'm going to flip this upside down. So 3 over 1. And if it is negative, I'm going to make it positive. And if it is positive, I'm going to make it negative. So I'll just leave this negative. And really, you can write this as just 3. That's what 3 over 1 is. If you write 3 over 1, that's fine. I'll give you full marks for that. No big worries. All right, what about this next one here? Let's see, bigger numbers, but not a problem. Let's see, 14 minus 8 over, let's see, 20 minus 12. This is going to give us, let's see, I believe 6 over 8, and that can simplify down to, just double checking 6. Sorry, just double checking myself. That can simplify down to 3/4. So the slope here would be 3 over 4. That means the perpendicular slope would be negative 4 over 3. We're just flipping it, and if it's positive, make it negative. If it's negative, make it positive. This one here, let's see, I see y values are the same, so this is going to be maybe a little tricky. 7 minus 7 over 8 minus 2, so we would get 0 over negative 6. Well, that's just 0. It doesn't matter what's in the bottom of this, so we're looking for a 0 slope here. And if we flip this upside down, we would get negative 6 over 0. Anything divided by 0, anything over 0, is undefined, and that's what the perpendicular slope would be, undefined. All right, one more slope. Let's see, we'll have 10 minus 8 over 15 minus 7. So you would get 2 over, let's see, that's going to be 8, I believe. So that would be 1/4. So the slope here would be 1/4, and the perpendicular slope would be negative 4, or negative 4 over 1. It's totally up to you. All right, let's see. Graph a line with the slope of negative 3 over 5 that crosses through the point 2, 2. First thing I'm going to do is find my point, 2, 2. And the next step would be finding out that slope. A negative slope is going to be pointed in this general direction. I like kind of keeping that in my head as I'm graphing these out so I know that I'm doing it right. First thing would be change of y. So we'd go down 1, 2, 3. Then we go over 5. 1, 2, 3, 4, 5. Right on the edge of the graph, actually. That is going to look something like that. I'm not looking for perfection here. I'm just trying to find at least the 2 points with the right slope. I know that if you go up 3 and over, let's see, 5, it really should be crossing here. I'm not going to get out a tape measure and knock off points for anything like that. So as long as we're in the right ballpark, as long as it crosses through this point, or the point that I give you, rather, you'll get full marks. This one is just writing linear functions. If I don't specify like a point, that's fine. Just write it out. If I just say the slope is this, and that's it, just give me any line with that slope. It can be as complicated or as simple as you want. I think I'd prefer simple, just because it'll be easier to grade, but it's totally up to you. All right, slope of negative 3 over 2 crosses through 5, 1. I'm just going to use point slope form. No reason not to. So y minus y1, which is right here, that's y1, the 1, equals the slope, which is negative 3 over 2, x minus x1, which is 5. That's what we're looking for there. Let's see. Write an equation for a line that satisfies the following conditions, perpendicular to a line with a slope of 1. So the slope of 1, and we're looking for the perpendicular slope. That would just be negative 1. If we think of 1 as a fraction, it's 1 over 1. To get perpendicular, we flip that and make a positive and negative. So it would be negative 1 over 1. So that's what we're looking at right there, just negative 1. This is really quite simple. So y equals negative x. If you did negative 1x, that's fine as well. You don't need the 1. It's not necessary. Y equals negative x. You can put, plus 7 or whatever you'd like. As long as the slope is negative 1, that's all I care about. Let's see, is nonlinear. Anything with x raised to a power greater than 1 would be nonlinear. So I'm just going to say y equals x squared. That's all we need. Crosses through 3, 8, and 1, 1. This one's going to require a little more work. We'll have to figure out the slope and then graph it through a point. I already know my point's going to be this. It's just easier to write out. I won't mix anything up, my x or my y. So let's find out the slope first. 8 minus 1 over 3 minus 1. Notice I'm using these points first just because I know it'll make it negative. It doesn't matter. I'm sorry, that'll make them positive. If I flipped these, then I would have a negative on top and bottom. They'd cancel out. You should get the right answer regardless of which way you go. So I'll get 7 halves here, and then I'll use my point slope form. Y minus 1 equals 7 over 2 x minus 1. So I'm using the point here and the slope that we figured out that would have to cross through those 2 points. If I used this point instead and plugged it into this function, we'd still have the same answer, or the right answer. It wouldn't be exactly the same, but it would be the same equation of the same line. Let's see, this next one here. Y-intercept at 1, slope of 2. I'll just use point slope form. Y equals mx plus b. Slope is 2x plus b, and the y-intercept of 1. There it is. Slope of 0 crosses through 2, 4. I'm sorry, 2, 7. Don't know where that 4 came from. Let's see. I'll use point slope form just to show you that kind of how this will work. So y minus y1, 7, equals 0. That's the slope. X minus 2. Doesn't really matter. I'm sorry, what goes in here. If the slope is 0, this is all going to equal 0. So if I got y minus 7 equals 0, that works out. Or you could give me y equals positive 7 by adding 7 to each side and simplifying. Totally up to you, but that's what we'd be looking for here. Let's see, x-intercept at negative 5, slope of negative 2/3. Be careful with this one. X-intercept can be kind of a little tricky. You can't put that into point slope form as easily. So I'm just going to figure out what the x-intercept actually is as far as a point, and then use point slope form. So if the x-intercept is at negative 5, that means y is at 0, and the x is at negative 5. And then we can graph it out. Y minus 0, so we don't even really need to write that out. I'm just going to go y equals, let's see, negative 2/3 x plus 5. That checks out. All right, perfect. The next one that we're looking at here would be this one here, is linear. This can be as complicated or as simple as you want, so long as we don't have any x's to any powers. Y equals x is what I would go with. Just keep it simple and short. Here's another 2 points. Need to find the slope and then graph it through a point. I'm going to use this one. That's just 5, 5. I won't mix up the x or the y. So to find the slope, I'm going to say 8 minus 5 over, let's see, negative 6 minus 5. So this is going to be very negative. We'll have 3 over 11, 3 over negative 11. So that's the slope we're working with. And then I'll just pick a point. Y minus 5 equals 3 over 11, but make sure that it's negative, negative 3 over 11, x minus 5. And we're set. An undefined slope. This one's kind of tricky as well. It has to be totally straight up and down. And the easiest way to express that is just x equals any number. I'm going to say x equals 2. It could be anything, any solid number. You could even say x equals pi, and it'll just be a vertical line at 1, 2, 3.14 right here. We'll call that pi. It will just be a vertical line going straight up and down. All right, that's it for section 2.4. 2.5 is all about scatter plots. I'm actually going to use a straight edge for this. Let me find one here. All right, got it. So let's see. This I'm also not going to be incredibly picky with as far as the line goes. It is also only worth 1 point, so don't stress about how accurate this line is. I would like it to be as straight as possible, so if you can get a straight edge, please do, but well, I take that back. Don't worry about how straight it is. Just draw one out that's as accurate as you can. So I am going to kind of just slice all of these points right in half. Oh, that's the wrong button to use. There we go. All right, good enough for me. Let's see. That's 1 point already. The next would be select 2 points on your line and calculate the slope. I really want you guys to circle the points that you're using so I can follow along with your work. I'm going to use this one here. And let's see, where's another good point I can snag? One further away is often best. Let's see, this one's a little bit off, but I'm still going to use that intersection of data. So we're at 52 right here, and we are at, let's see, as far as sales in dollars, we're at $200 right here. So I'm at the point 52, 200, and I'm at the point right here, 790. All right. I'll use those 2 points to calculate the slope. So let's see, 790. Okay. Oh, I'm doing this totally backwards. Let me back up here. This is 9,700. All right, that makes a lot more sense. Okay, so we'll go 700 minus 200 over 90 minus 52. So I'm going to punch in the 90 minus 52 onto my calculator here. We get 38. And that's 500 over 38. And I am going to just approximate. I'm not looking for anything super exact here. I get 13.157, so I'm going to say this approximately equals 13.16. You don't need to get any more precise than 2 decimals. Let's see, using a point on your line and the slope, write a prediction equation. I'm going to use my 9,700 just because they're nice rounder numbers. So let's see. I'm going to write that out now. 9,700. Yep, 700. And write out the prediction equation. I will plug in, let's see, y minus y1 of 700 equals 13.16 x minus 90. That's all I'm looking for there. Using your prediction equation, estimate the total sales on a day with a high of 100 degrees Fahrenheit. Okay, that would mean we plug in 100 for that X value and then just calculate everything out, crunch it all out. So we'd get, let's see, y minus 700 equals 13.16 times 100 minus 90. So we get y minus 700 equals 13.16 times 10. Y minus 700 equals 131.6. And that would give us y, once we add 700 to each side, that would give us y equals $831.60. That's what we're looking for there. If you don't put it into dollars or whatever the scatter plot that I give you, units wise, that's okay. I might take a point off in all honesty because we do want units. That's what we're trying to estimate the total sales on the day, but that's to be determined, I suppose. Let's see, graphing some inequalities. There's one at the very tail end here you may have noticed is worth 4 points versus the other just being worth 2. That's just because it's more complicated. getting it into the correct form can be a little bit of a struggle with that one. So just take your time on it and don't stress, and you'll get there. All right, first thing I'm going to do here is add 2 to each side. I would actually cancel them all out. So I'd get y is less than 3x. So we know an intersection is here at 0, 0 with a positive slope of 3. I'm going to use my straight edge here to graph this out. Close enough. Now we need to pick a point that's not on this. We've been using the origin if it doesn't cross through the origin, but this one does. So I'm going to use the point 1, 1. Just plug that in. So 1 is less than 3 times 1. 1 is less than 3. This is true, so we would shade on the side with that point. All right, next one here. Let's see. I'm going to subtract 3x from both sides. Subtract, not add. What am I doing? Subtract 3x, so I get 4y is less than or equal to negative 3x, let's see, plus 5. And then I can divide by 4 everything. So I'm going to get y is less than or equal to negative 3/4 x plus 5 over 4. So the y-intercept here would be 5 over 4, or 1.25. And if you just kind of approximate that, that's okay. I'm not looking for exact graphs here. Whatever way you can graph this that is easiest for you is totally okay. I'm going to go, let's see, change of y is negative 3, so we'd go down 3. That's 1, 2, about right here. And then over 4. 1, 2, 3, 4. All right, I'm going to use those 2 points and graph everything out. And then check a point. We can just use 0, 0 because it doesn't cross through. Oh, I just realized I am not checking. This needs to be a dashed line. Let me write that in right now. Oops, not erase. There we go. All right, perfect. This next one is solid, though. That's a step that I always forget. All right, so we're testing a point. We're plugging in 0 and 0. So this would go to 0. The negative 3/4 would go to 0. And we'd just be left with 5/4. 0 is less than 5/4. So this testing point, the origin, checks out. We're going to shade that side of our inequality. Next, we would have this one here. All right, I'm going to write in big bold letters, dashed, so I don't forget. And this one is solid. Just looking ahead and knowing what I'm going to mess up on. All right, I'm going to divide each side by negative 2. So I would get y is less than, because we divided, this is going to switch, negative 3 over 2x minus 3. That's what 6 over negative 2 would be, negative 3. All right, we have the y-intercept at negative 3. The slope is negative 3 over 2, so down 3 over 2, up 3 over 2. And we're going to draw this dashed line. All right, easy enough. It does not cross through the origin. We're going to use 0, 0. Negative 3. 0 is less than negative 3. This is false. So we would shade the other side of the inequality. We'd shade this side here, because 3 is definitely larger than a negative 3. Uno mas, and we are all done with the packet. I'm going to get all of my y's over to one side by adding a y here. So I'd get negative 2y plus 6 is greater than or equal to, let's see, 2x plus 2. I'll subtract 6 from each side, so negative 2y is greater than or equal to 2x minus 4. and then divide each side by -2, everything by -2. We would get y. And remember, this flips less than or equal to -x plus 2. So the y-intercept is at 2. The slope is -1, which means it's going to go this way. And it is a solid line. So I am going to graph this out as best as I can. I'm not looking for perfection. Just something that's obviously very close. You know what you were doing. And then I'll plug in zeros. 0 is less than or equal to 0 plus 2. So 0 is less than or equal to 2. That checks out. We shade that side of our line. And that's the whole study packet. If you guys do have extra questions, please jot them down, circle them, or make a note to yourself to ask in class before the test. I'm more than happy to answer questions, especially on this study packet, if it looks like you guys went through them, and clarify anything that you need. We will see you there, and I hope you guys have a good weekend.